Hello and welcome to this tutorial in the NPTEL course Machine Learning for Core Engineering Disciplines. So far we have learnt some basic concepts in machine learning as applied to core engineering disciplines. Now it is important that you are all able to implement whatever you have learnt by using a programming language, and these days for many of us doing ML the programming language of choice is Python. So in today's tutorial I want to give you an introduction to Python. Obviously it's as with any programming language, you cannot do justice to the programming language if you try to cover it in a short period of time. However, I have put down some material that I hope will be useful to you. If you are already proficient in Python, you may just want to glance over this quickly, but if you are new to Python, obviously you should take time in doing this, and hopefully by the end of this and your own practice you will become very good at Python, which is important for running and testing machine learning problems. So let us go ahead and get started. So I want to begin today's tutorial with an introduction to Python, right. So what exactly is Python? So Python is a high level programming language, right, in which you can write commands, and it was first introduced in the year 1991, and Python has become increasingly popular especially in the realm of scientific computing and machine learning. So if you want to look at various types of problems that you encounter in the core engineering disciplines, then Python is actually a must know these days. So Python has several packages that can be used to augment its capabilities beyond traditional programming, right. So typically in C or C++ you are used to traditional programming, right, which consists of if else statements, for loops, while loops, and linked lists and assignment of variables and so on. However, in Python, just like MATLAB, you can do much more. You can, for example, graph and plot things. So if you want to let us say plot complex functions and understand whether it is a one dimensional function or two dimensional function and so on, there is something called MatplotLib you can use in Python. Python also has modules for scientific computing, and this is known as SciPy, spelled SEIPY, and for linear algebra, which is spelled as Numpy. Now since it is difficult to install and keep track of several such packages, one typically works with a Python distribution manager, and one such distribution manager is called Anaconda, right. And what you can do is you can click this link, right, and you can try to open Anaconda, and similarly I have provided a link for Python here which you can access. Now the Anaconda installer for Windows and Mac, so we do not know what kind of machines you are using, but whether you are a Windows user, a Mac user, or a Linux user, you should not find much difficulty in using these tools. So the Anaconda installer typically not only installs Python, but also some associated packages like Numpy, Pandas, and MatplotLib. Now for Linux the installation procedure is slightly more complex, but it can still be done, right. So I encourage you to open this particular link and install it. If you are a Linux user, for Windows and Mac it is slightly easier. Upon installing Anaconda, one obtains access to an IDE. It is an interactive development environment, and that is called Spider, and this environment can be used to develop and test Python code. The Spider is also available separately in case you want to download it at spider-ide.org. Now one of the nice things about Spider is it also comes with an interface called the Jupyter notebook, which is used to execute and write Python code in an interactive manner, right. So you can code line by line instead of the traditional programming mode wherein you are writing large pieces of code and then testing them at the end, and then you do not understand where the error was made. In Jupyter notebook you can go cell by cell, right. So you can do programming cell by cell. and then you can evaluate each cell and understand what is really going on. And like I said, one typically uses Spider for working with standalone Python code, or the Jupyter notebook when you want to work with this IDE, interactive environment, right. Okay, and this extension file is either a Py or an IPy notebook, right, IPy NB. The NB stands for notebook here, and Py of course is Python. It is very easy to open Spider, right, on your computer, and for Jupyter you can use the GUI or follow the steps given below. So I am hoping that you are or will become familiar with the terminal. The terminal is a very convenient character user interface, CUI, which is available on Mac and Linux, and even on Windows there is now a terminal. There is a separate terminal for Anaconda, and you can use it to create a Conda environment by writing this line of code. Now these lines of code were tested, however you may find in some cases that there are certain problems. So I encourage you to use Google, and of course now you also have all these AI tools like ChatGPT and Gemini and Copilot, which can help you find out and diagnose any errors in the codes that I have mentioned here. Okay, so these are the code lines that are used to activate the environment, install the Jupyter notebook, and then you can open a Jupyter notebook by simply saying Jupyter notebook, right, and notice the spelling Y, right, in Jupyter. Okay, and that is of course because of Py here, right, because Py is short for Python. All right, so the Jupyter notebook typically opens in the web browser, right, and it is very nice. Once it opens, I will show you some screenshots slightly below, so you can get a feel for how this Jupyter notebook looks. If one decides not to work with Anaconda or Spider, you can still install Python and the associated packages manually on a Linux or a Macintosh, and to do so you can use the commands that I have mentioned here. Feel free to pause this video whenever you have to type in the command on your computer. This is done with pip install python 3, and if you use a Macintosh, you have to use a package manager called Homebrew, right, and once you get Homebrew you can then do brew install and these commands. So this is the command for installing Python on Mac. So it is brew install python 3, and Python 3 is one of the latest versions of Python. You can also install Jupyter separately on a Linux machine, and the command of course is brew install Jupyter on a Mac. Now with all the installation done, right, which is sort of the mundane part of getting started, but still something that is important, we can now proceed to understand some simple commands in Python. So let us go ahead and look at this, right. So like I said, if you type the command Jupyter notebook, the programming environment will open right in your web browser, and you will get a screenshot which looks something like this, right. So there is a files tab, there is a running tab, clusters tab. You can use these buttons to quit, log out, you can upload a file here with the upload button, you can click on this new, and you can create a new notebook. So right now when I had initially started, the notebook list was empty, however as you create more and more notebooks, this list will get populated. So you can create a new notebook, right, by clicking on new python 3 IPy kernel as shown below, right. So this is the option that I want you to click under new. You can of course create things like files, folders and terminals, but right now the IPy kernel is what we want. Alright, so once you click on the python 3 IPy kernel, a new Jupyter notebook will be created, and the initial screen will look as follows, right. So there is a place, right, for you to type a command. So any command will have to be typed here. So the cursor will take input. So few things here to note. The name of the notebook by default is untitled and it says unsaved changes because we have not yet saved the changes. You can click on this notebook name and you can rename the notebook as per your preference, right. There is also a lot of other buttons here. This is the save button, cut, copy, paste, all these buttons do exist here. There is a run button, there is a stop button and refresh button and so on and so forth. I do hope that as you are watching this video you are trying out these commands which I will be telling you on your computer because it is important for you to gain practical experience in Python. Now in Jupyter each command is written in a cell and can be executed independently. Remember I told you this is the advantage of using these interactive development environments like Jupyter. You can do things step by step rather than having a massive piece of code. So these are some of the standard commands, right. I am just defining a variable and then printing it. So a equals 1 print a and so on. Now I am telling you a series of keyboard shortcuts. These will become very useful as you go on. So it will save a lot of time because instead of using the mouse you can use these shortcuts. So to execute a cell you have to do shift enter, and if you are more comfortable with the mouse you can obviously also select cell, run cells from the menu bar. Now notice that each cell is assigned a number by Python. So this cell is assigned the number 1, this cell is assigned the number 2 and so on and so forth. To delete a cell you can choose edit delete cells from the menu bar, or you can use the keyboard shortcut DD, which means that you press the D button twice on your keyboard and that particular cell will get deleted, right. Now here are some more useful keyboard shortcuts, and a note to Mac users that they should replace control by the command button. So control plus enter runs the current cell and stays in the same cell, whereas shift plus enter runs the current cell and moves to the next cell. Now while you are in the command mode, right, the following commands will be useful, right. You can do a lot of things in the command mode, and note that if you press escape, right, to confirm using a blue boundary button around the cell, right, this will confirm if you are in the command mode, and when you are there you can press enter which will take you to edit mode. You can add a cell above the current cell by using the letter A on the keyboard. You can add a cell below by using the button B. You can press D twice to delete the current cell, which I had already mentioned a little while ago, and Z is undo cell deletion and L is show the line numbers in the cell. So if you have a cell that is particularly long and you want to see the line numbers, then this L can be useful on the keyboard. Alright, so that is in the command mode. Now if you are in the edit mode, right, this is indicated by a green boundary around the cell. When you are in the edit mode, this is indicated by a green boundary around the cell. The following other commands can be useful. You can comment or uncomment the selected lines by control plus slash forward slash. You can press tab to indent the selected lines by one tab character, and you can shift plus tab to unindent the selected lines by one tab character. Now as you all would probably already know, apart from integers, variables can also be used to store text as well as boolean data. So I am showing a few commands here. So in this line I am defining the variable b to be false, so this is boolean. C equals machine learning, this is of course text, so you can print b and you can do various things. So here what I am doing, I am taking C and D and concatenating them with each other. So this C plus D is basically concatenation. So you are putting the two strings together, so then it becomes machine learning parenthesis ML, right, which is C and D put together. Now a type of the variable can be obtained using this function type. So type of A which we had defined long ago is an integer, b is of the type bool, which is boolean, and c is of the type string, which is shortened to str. I want to emphasize that other typical programming constructs like if, else and for loops and other types of loops are definitely available in Python, right. However, we will not spend time in covering these. There are many other good resources for learning about these type of regular programming constructs. This is because our main focus in this course is machine learning. Now, one important thing that may be different for those coming in from MATLAB and those coming in from the C++ type of programming is that indentation is extremely important in Python, right. Indentation is extremely important in Python, and if you do make mistakes with indentation, the code will give errors. So, special attention must be given not to mix indentation made using tabs and spaces. So, if you end up mixing tabs and spaces, you can have difficult to diagnose errors, and that will certainly be problematic. You do not want to do that, right. You do not want to make errors which will take like hours to diagnose and ultimately to realize that you just mixed up tabs and spaces. So, pick one and stick to it. Alright. So, going forward, I wanted to remind you that there are several scientific computing packages in Python, right, and in particular we will use this Numpy library for helping us carry out numerical operations on matrices and arrays, right. Like I said in several lectures ago, that linear algebra forms an important part of machine learning, right. So, this Numpy library is very similar in syntax to the programming language MATLAB. Now, the difference is that MATLAB is a commercial software, so it costs a lot of money, whereas Python and all its these libraries are all open source. Another useful Python library is called SciPy, and this offers various algorithms related to linear algebra, optimization and integration of functions, interpolation of data. It allows the use of special functions like the exponential function, logarithmic functions, trigonometric functions in Python, and advanced operations like fast Fourier transforms, signal and image processing, and the solution of ordinary differential equations. So, if any electrical engineers are taking this course, they may find the features of SciPy particularly useful. And of course, all core engineering disciplines do involve ordinary or partial differential equations for which there are tools and functions available in SciPy. Finally, apart from Numpy and SciPy, MatplotLib is a graphing and visualization library that allows you to create nice 2D and 3D plots of data processed in Python, right. I will now briefly show the installation instructions for these packages one by one, right. Now, if you are using Anaconda, many of these packages are already available, right, but for various reasons someone may want to install these things separately, and then you can follow the series of commands that are listed here. For the sake of brevity, I will show these commands and then proceed to go ahead. However, you are free to pause the video at any point if you want to execute some of these installation commands on your computer, right. So, these are the simple installation commands for Numpy on Linux or Mac, and then once you have installed it, you will be able to load the Numpy module by using simply import Numpy, right. Now, there is Numpy, although it is just 5 characters, it can take some time to write this out if you want to use functions from Numpy. So, a small modification is often done to create a shorthand representation for Numpy. So, if you write import Numpy as NP, then you can use NP to refer to Numpy going forward. So, this will allow us to refer to Numpy as NP in our Python code, thus making us more efficient in writing. In a similar manner, you can install SciPy and MatplotLib on your machine and load these into your Jupyter notebook. Okay. So that tells you how we can load NumPy. Now what if we want to handle these matrices that we encounter in machine learning in Python using the functions available in NumPy, right. And before you handle matrices, obviously vectors are a simpler construct to handle. So let us see how we can handle vectors. So the snippet given below uses NumPy to define two vectors in Python and carries out various operations such as addition, subtraction, multiplication by a scalar, as well as determining the dot and cross product of two vectors. So here I am importing NumPy, then I am defining these two vectors. The first vector is A, that is 1 2 3, and the second vector is just 4 5 and 6, and this is what is being done through this np.array command here, right. So this is a function, and then you have to enclose the vector in square brackets. You can print and check that whatever you have written is indeed stored in A and B, and then you can do things like addition and subtraction. So A plus B is, this is element wise addition, as is always done for vectors. So this is element wise addition, and this is of course element wise subtraction. Alright. So now you can use the functions np.dot and np.cross to determine the dot product and the cross product of these two vectors, and obviously when you are working with vectors these type of things are very important. The dot product is also known as the inner product, and this is particularly useful when you are dealing with vectors and in linear algebra. Now you should try and explore the various commands available in NumPy to handle arrays. We will now proceed to use NumPy to define a matrix in Python, and then to perform various operations such as calculating an inverse, multiplying the inverse with the original matrix, calculating the eigenvalues and eigenvectors of the matrix, and calculating the determinant of the matrix. Just to refresh your memory, what are eigenvalues and eigenvectors? So if you have a square matrix, you can define eigenvalues and eigenvectors using the equation Ax equal to lambda x. This is done for square matrices, right. So A has to be an n by n matrix, and these vectors x are called the eigenvectors, and the lambdas are called the eigenvalues. So you can use NumPy to find the eigenvalues and eigenvectors of a square matrix. So this is a square matrix that I have defined using the np.array command. This is the matrix -2 1 1, 0 2 1, and 1 2 2. So that is the matrix I have defined, and then through these commands np.linearalgebra.inverse, you can find the inverse of the matrix. You can multiply the matrix A with the inverse B that we have found. Obviously the result is an identity matrix, we are just checking that here 1 0 0 0 1 0 0 0 1, and you can find the eigenvalues and the eigenvectors of the matrix, right. So this is the equation used for determining the eigenvalues and the eigenvectors. Alright. Like I said, you can also find the determinant of a matrix A, and that is done using this particular command. So there are several more commands available within the linear algebra library of NumPy, which you can explore on your own. Some particular commands are allowing you to find the transpose of a matrix, the Hermitian, right, the complex conjugate transpose of a matrix, the trace, which is the sum of the diagonal elements of a matrix, and so on and so forth. Now you can also handle a lot of data in Python, right, and this is often essential because one stores data in comma separated value files, CSV files. These files can be opened, as you know, by Microsoft Excel. Now when we are creating a machine learning model, often our data, right, in terms of the features and the target variables will be organized into CSV files, right. So within Python you can use the Pandas package to read CSV and Excel files, and what we are doing here is we are reading an Excel file called physical feature data.xlsx, which contains data regarding the physical features for a 20,840 nanopore data in graphene. Graphene is a two-dimensional material which my research group works with, and we have come up with a library of about 20,000 nanopores in graphene as documented in this 2022 paper here, and I provided the link to download the Excel file here. You are free to work with the Excel file that we have provided, or you can use the Excel file for your own data set on which you want to do data analysis and machine learning. Okay. So there is a slight difference in the file name. So in the code the file will be called physical feature data.xlsx, but when you download it, it's going to be named slightly differently, data.xlsx. So you can make sure to change the name of the file in the commands I will be mentioning below, right. So these are the steps to download the file from the GitHub repository. So when you click one of these links, you will open a GitHub repository for this particular paper, and then you have to click on the button download, and like I said, I encourage you to play with a data set of your choice pertaining to your engineering discipline. One thing to note is that this read Excel command may not work out of the box, and one may need to use one of the following commands to open OpenPy Excel on your computer. Like I had told a little while back, these commands often change over the years, and with the use of generative AI, it's always better to diagnose any errors that may occur while running these commands. So what I am doing here now is I am importing this Pandas library as PD, and then using this read Excel command to read the data in the physical feature data.xlsx file, right. Now the moment you did that, it is showing the rows in the data set here, right, it is showing these rows here. So they are numbered from 0 to 2839. So numbering in Python starts from 0, and some of the columns are shown here. So I am storing things like the number of atoms removed to form the pore in graphene, number of zigzag atoms, armchair atoms at the edge, corner atoms, singly bonded atoms, and so on. So these are the features, right, and these are the data points here, right. So it is a huge high dimensional data set, and the data in the Excel file can also be stored in a data structure as follows. If you use the pd.readexcel command, and then you can see that it has been stored as a data frame. Now using this, one can determine the number of rows, which is essentially the number of data points here, and the number of columns, right, essentially features. Of course I have also stored the target variable, so this is not exactly the number of features, that is 2 plus the number of features, because I have 2 target variables in my data set. Okay. Now one useful tidbit is that if you press tab after writing the name of a variable or a package, that will show you a list of commands that can be executed. One can see now that there are 20,840 data points in the data set, and there are 24 columns in the data set. As I had mentioned little while ago, the first 22 columns contain the features of the graphene nanopores, and the last 2 columns have data on the target variables, the time to form a nanopore and the probability of occurrence of a given shape of a nanopore. Therefore there are 2 target variables and 22 features in our data set. One could access some rows from either the beginning or the end of the data set as follows. So if you type this, right, you would get access to rows 3, 4 and 5, remembering that numbering happens from 0, and if you did this you would get access to the last 3 rows, right, -3 is the way to indicate that you want to start from the end of the data set. Alright. Now one can also sort the values as per the data in a certain column and only display certain columns, right, because there are so many columns, 22 columns of features, you do not want to see all the columns. So here what I am doing is I am showing only these two types of columns, the number of removed atoms and the probability, and I am sorting the values in a descending order of the probability, right. So you can now see that the data is coming in descending order of probability, the highest probability here and decreasing, and I am also only showing, right, data from 0 to 5, right. So the first 5 rows are coming here. One can also use functions like max, min and mean to determine the maximum, minimum and mean value of a certain feature, right, and this is of course important in finding things like the sample mean, sample variance and other quantities that may allow you to statistically characterize what is going on with the data set. Of course there are inbuilt functions also to do these kinds of calculations. So here I have computed the maximum probability in the data set, the minimum probability in the data set and the mean probability of the nanopores in graphene in my data set. I have also included in this tutorial how you can plot data, right, and like I had mentioned earlier, this is done through the MatplotLib package, and for this purpose it is useful to load this pyplot module from MatplotLib, right. So I am loading matplotlib.pyplot as PLT and then you can make several types of plots. So you all know that data can be visualized using a bar plot, scatter plot and so on and so forth. So here I am showing a histogram of the data. So plt.hist, that gives you a histogram, and you can see that you can see the frequency of occurrence of various nanopore formation times. Notice that this distribution is not a normal distribution, this is a skewed distribution. With a tail, right, the tail exists at the front here. Another example is that of a scatter plot, right. You can just do a scatter plot between the probability, which is one of the target variables, and the formation time, which is another target variable, to understand the relationship between these two. So here you can see approximately a decreasing relationship between the two. If you have a larger formation time, you are going to have a lower probability, as can be seen here. Right. Now obviously we are at too early a stage to implement ML models, we have just started to learn about them, but I want you to already install some of the ML based Python packages. This is scikit-learn and PyTorch. Now scikit-learn, also known as sklearn, is a Python library that offers several ML algorithms for classification, regression and unsupervised learning. So whether it is linear regression, logistic regression, support vector machine, Gaussian process regression, principal component analysis or k-means clustering or k-mean clustering, you will find it in sklearn. On the other hand, PyTorch is a Python library for implementing deep learning models, right. If you want to do neural networks, then PyTorch is the way to do it in Python, right. These two packages, if you install now, you will be able to use them as we move forward in this course. The installation procedure for scikit-learn is quite simple. Again, it is done through pip install, right, and once you have installed it, you can load it into Python using import sklearn. A similar command will be useful to install PyTorch, which is just called torch, and you can find more information about how to install torch here, right. Here before ending, I just want to alert you that sometimes you may get various errors, right, when you try to import these models in Python, and this may happen if the Python installed on a computer and the notebook for Jupyter have different versions. So if you want to diagnose the problem, One way to do it is to find out the version in Python that is on your computer and the version that is in the notebook and try to make sure that these are the same, right. So, this brings me to the end of this tutorial. In today's tutorial I provided a very basic introduction into the Python programming language, and while we did not focus on things like if else statements or constructs such as for loops or while loops, we did spend some time in understanding how libraries such as Numpy, SciPy and MatplotLib are useful. So, while you can use various linear algebra commands in Numpy like finding the inverse or the eigenvalues and eigenvectors of a matrix, you can do a lot of graphing in MatplotLib. I also showed you how you can import Excel or CSV files into Python right through the use of the Jupyter notebook, and this is important if you have data sets where the data comes from an Excel file. Finally, I showed some plotting commands in MatplotLib, and of course as you go along in this course you will become more and more proficient with using Python. I hope you found this tutorial useful, and I hope to see you in the next lecture.